Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ramiatul Adawiyah binti Sabri, 1170854. Today, my group will represent to you about the physical properties of nanomaterial using the instrument of BET and TEM. My group numbers is Haja U3 1170852. Okay, first of all, what is BET? BET is an acronym from three people who introduced the BET theory, which is Stephen Brunauer, Paul Hughes Emmett, and Edward Teller. Three of them produced the BET theory at 1938. Okay, actually, what is BET? The BET is used to explain the physical absorption of gas molecule on a solid surface, which we can see the nitrogen absorption analysis is used in BET. Okay, we focus on three section area, which is the surface area of material that we want to analyze. Second is pore size distribution, which the pore in the pore size on the molecule, on the surface molecule. And third is surface analysis. Okay, on the surface analysis, we can know the BET is a non-destructive sample using non-destructive sample, and it have no covalent interaction, which means it has an interaction, but there is no bond between the molecules. Okay, for the BET assumption, uh, the assumption means the researcher assume the principle before the research is taken. Which the first, the gas molecules behave ideally. This means the homogeneous surface on the molecule, and gas molecules refer to the nitrogen gas. Okay. Only one monolayer forms, okay, which you can see in the picture. The monolayer form on the molecular surface. And third is all sides on the surface are equal. Okay, this means there is no empty space on the molecule, which the nitrogen gas is fully filled the surface. Okay. Fourth is no adsorbate material surface interaction. Okay, we recall that what is adsorbate and adsorbent. Adsorbate is the material that absorb on the surface, and adsorbent is the surface adsorbate is absorbed. Okay, so this means between the adsorbate, which in this case is nitrogen, is have no interaction with material surface. This means the nitrogen gas doesn't make any chemical interaction on the surface. Okay. Lastly, the nitrogen molecule is immobile. Okay, as we know, if mobile, it cannot be absorbed monolayer like this, right? Okay, now is the BET theory. First, BET is a homogeneous surface, okay, because the gas behave ideally, as we can see from the previous slide, the previous picture. Okay, second one is no lateral interaction between molecules. Okay, this means the gas behave ideally. Okay, and this all surface sites have same absorption energy or adsorbate. Like we can see in this picture, The surface side here have same adsorption energy for the adsorbate, which is nitrogen, is adsorbed. Okay, this is the same meaning as there is no empty space on the layer of the surface. Okay. The adsorption on the adsorbent occurs in infinite layer. This means it doesn't mean that the layer should be a monolayer only, but it can be multi-layer. Okay, we go to the BET instrument itself. As we can see, this is the vacuum or the flow of the gas. Is the heating mandrels because we will heat the sample. This is the degas temperature control, which we can control the heat. And in the next slide, we will see the temperature needed to heat it. Okay, this is the status and data display. This is the analysis selection keypad. At the top of the instrument, we can see the system status display. And here we put the sample. And here this automated reward elevator. Okay, we go to the working principle of BET. Okay, first we need to degas, which we will heat and evacuate. Why we need to heat and evacuate the sample? This is because to keep the nanoparticle dry and want to evaporate the water on the surface. Okay, next, we need to evacuate, apply the vacuum into tubes. Okay, we do this to ensure all the water molecule is evaporated. For the third process is the volume. We measure that volume which helium. This is the same aim is to speed up the analysis. And the fourth one is we evacuate for the second time because we need to clear up all the pores. We doesn't want any impurities on the pores. We just want the um, empty pores with the adsorbent only. And this, okay, these two process is being told in this cycle in this picture with which I have explained earlier, which the adsorption of nitrogen occur on the surface and it forms adsorption isotherm, which we can see in the next slide later. And this is the desorption, which we will evacuate nitrogen for desorption isotope. Also, we will see in the next slide. So we need to always remember this cycle will which the pore first need to be filled up on the surface and then it forms a monolayer and then it continue to fill up the pore and lastly the pore is complete to be filled. Okay, for the insertion isotope which I told you earlier, um, as you can see, number one, okay, this is the formation of monolayer. We can see how the adsorption isotherm happen here at the face of monolayer. Then we go to the second and third phase, which it happen multi-layer, and we look at the adsorption isotherm started to different from the first, from the monolayer. Okay, now at number 4 and 5, we can see the condensation process occur, which the pore is fully filled with the nitrogen gas, which this happened absorption isotope right here. And the number 6 is absorption isotope is complete. Okay, for this, the sample example of boron nitride, I refer to this article where we can see the different morphology of boron nitride in dye adsorption. Okay, for the physical measurement that we use in BET, uh, as I stated here, which we use this BET instrument itself, and BET need to be preheat at temperature of 100 degrees Celsius for 1 hour. This is to remove the absorbed gas and moisturize. As I told just before, it needs to be clear up all the uh, pores. It doesn't need any impurities on the surface. And this is the temperature range that we use to get our sample is between 10 to 350 degrees Celsius. Okay, for the next slide, for explanation on TEM will be continued by Siti Haja. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And I am Siti Haja binti Amarisri, and I will proceed to present another microscope, which is transmission electron microscope. Transmission electron microscope is a technique used to observe the features of a very small specimen. The specimen is almost an ultra thin section, which is less than 100 nanometer. The physical properties when a sample is being analyzed by TEM is imaging and particle size and shape. Why do I highlight the particle? Because, as I said before, TEM required a very thin and small specimens. This is the example. As you can see, the sample or the particle is clearly seen under the microscope. And why do the specimens must be very thin? Because so that the electron are able to pass through the sample. Okay, to the next slide. But before that, what is the advantage of TEM? TEM will provide higher resolution image than SEM, because SEM can only scan and view on the surface of the sample. Get to the TEM instrument. This is the TEM instrument. TEM instruments have three essential systems, which is the electron gun, the image reproducing systems, and the image recording system. For the electron gun part, the filament will produce the electron. The filament will produce an electron, and the electron gun will produce the electron beam and condenser lens, which focus the beam onto the object. For the second part, image producing system consisting of objective lens, movable specimen stage, and intermediate and projector lens, which will focus the electron passing through the sample and provide high magnified image. For image recording system, it will convert the electron image to an image which will be perceptible to human eye, and it will consist of fluorescent. Next, we will proceed to the working principles of TEM. First thing first, we must to prepare the sample. In this picture is an example of aluminium nanoparticles, but I will explain to you the general method of any sample. First thing first, we must to cut the specimen's tissue into a very small and thin using an ultramicroton, and then we put the tissue into a chemical solution to preserve its chemical structure. After that, we must dehydrate the samples and remove all the excess water. After preservation and dehydration, we put the sample, like on this picture, we put the sample onto a very thin and hard plastic and put it on the sample stage, like I explained before, on the TM instrument. And then we will put drops of lead to the sample to stain the sample. And for the next step, as the sample have been put on its stage, an electron beam will be produced and will accelerate and focus onto the sample. And for the third step, the sample, after it being focused on the sample, will produce an image by the objective lens. And then we will proceed to the sample example, sepiolite. This is not under the EM microscope, but is the structure of sepiolite. Based on this article, study on pore distribution and formation role of sepiolite mineral nanomaterials. Based on that article, this is the microstructure of sepiolite minerals under TEM microscope. Okay, and I will proceed to the results of these articles. This is the microstructure of sepiolite minerals under TEM microscope. As you can see in A, the sepiolite samples are within diameter within 60 to 100 nanometer fibrous minerals material. And for B, as you can see, it have a prismatic size of sepiolite samples with uneven surface. And C, there exists of prominent distance of microconvex. This is the result shown by these articles. Okay, and I will proceed to the comparison between the transmitted electron microscope TEM versus scanning electron microscope SEM. As the name suggested, TEM use transmitted electrons while SEM use scattered scanning electrons. Because of TEM use transmitted electrons, which the electrons that can pass through the thin sample, provide valuable information rather than SEM, such as the inner structure of the sample, the crystal structure, the morphology, and the shape or the size, while SEM just provide the surface of the sample. For the specimen thickness, as I stated before, TEM must use specimens that less than 150 nanometer, while SEM can use any sample, can use any width of sample, but not very large. For image formation, TEM have a direct imaging on fluorescent screen. As I stated before, that why use fluorescent screen? Because it is perceptible to the human eye. While SEM use electrons captured and counted by detectors image on a PC screen. Okay, then we proceed to the TEM versus SEM instrument. For TEM, as you can see, the samples are positioned at the bottom. The samples are located in the middle of the column. The transmitted electron pass through the sample and also pass through the lens, the objective lens, the intermediate lens, also the projector lens. An image is directly shown on the fluorescent screen. For SEM, the sample are positioned at the bottom of the electron column. As you can see, position at on top the objective lens, and the scattered electron are captured by the electron detectors. As Iza presented before, SEM have 3 types of detectors. Okay, for the next slide, this is a silicon image under TEM versus SEM microscope. For SEM, it have maximum field of view far larger than TEM. For A, SEM image offers information about morphology of the surface, while TEM offers information about the inner part of the structure. As you can see, it's major differences between TEM and between SEM and TEM image. Okay, that's all from our group. Thank you for paying attention. And Assalamualaikum warahmatullahi wabarakatuh.